Good morning. Today we are going to start new topic, a simple one. It is logic. Now, what is logic? Logic is basically a science of accurate reasoning or thinking. It consists of the rules used in drawing correct conclusions from given information. We know that in every subject, there is certain vocabulary. So in case of logic also, it has its own vocabulary. So in this topic, first we discuss terms and symbols which are used in logic vocabulary. And then we will discuss methods of analyzing sentences. And finally, we will discuss a simple application of logic, which is in switching circuit. So the most important term in this topic logic is statement, which is also called as proposition. This is an important definition. Statement, that is proposition. A declarative, that is assertive sentence. Listen to me carefully. A declarative, that is assertive sentence, which is either true or false, but not both simultaneously, is called a statement or proposition in logic. I repeat this definition. It is an important one. A declarative, that is assertive sentence, which is either true or false, but not both simultaneously, is called a statement, that is proposition in logic. And therefore sentences which are incomplete or imperative or interrogative or exclamatory or suggestive are not taken as statements in logic. Note that a statement is either true or false, or equivalently either valid or invalid. It cannot be both true and false, and also neither true nor false. That is, we cannot say 50% true, 50% false. So this middle situation, half-half, is excluded. And this fact is known as law of excluded middle. Now, these statements are usually denoted by small letters P, Q, R, S, etc. Suppose I will not write that. Suppose I write these sentences. The first one is the sum of two odd integers is an odd integer. Can you call this sentence as statement? Yes, this sentence is a statement. Now you will say, but sir, sum of two odd integers is not an odd integer. Have I said that it is true? Have I told you about the truth value of this particular statement? No, I'm just saying that this is a statement, right? But if I say that x plus 4 equal to 11, is this a statement? This is a sentence, but is it a statement? It is not, because if x is 7, it is true. If x is other than 7, it is not true. And therefore, this is not a statement. We are going to call this as open sentence. If I say that Mumbai is the capital of India, is this a statement? Yes, it is. Obviously, it is not a true statement, but it is a statement. Okay. If I say that this is black in color, this is black in color, is this sentence a statement? No, it is not. Why? Because it all depends on that particular object for which this is used. Okay. If I say that if a triangle is an equilateral triangle, then each of its angle is of measure 60 degree. Is this sentence a statement? Yes, this sentence is a statement. Okay, I hope you have understood the meaning of the word statement. So every sentence need not be a statement. If a sentence is assertive, that is declarative, then only it is called as statement. Okay. Now, next important concept is truth value of a statement. See, this part is not at all difficult. Truth value. A statement that is proposition is either true or false. This truth or falsity of a statement is called the truth value of the statement. If a statement is true, its truth value will be denoted by capital T. And if it is false, then its truth value is denoted by capital F. As simple as that. Consider the statement, the sum of two odd integers is an odd integer. Suppose we denote this statement by P. So P is a statement, sum of two odd integers is nothing but an odd integer. We know that this is a statement, rather the sentence P is a statement, but it is true? No. 3 plus 5 is 8, which is not an odd integer, it is even. And therefore we say that the truth value of this statement P is nothing but F, as the statement is false. In some cases, 1 is used to denote that the statement is true, and 0 is used to denote that the statement is false. That is, 1 corresponds to P and 0 corresponds to F. Is that clear? Now we discuss logical connectives. I have written two statements, 3 plus 4 equal to 7, and second, 2 is even and minus 3 is odd. Can you differentiate between these two? The first one is a simple statement and the second one is a compound statement. So what is the difference between these two? A statement which is not a combination of two or more statements is a simple statement. So 3 plus 4 equal to 7. I can say that the set of all natural numbers is finite. Now don't say, sir, this is wrong. I'm saying that this is a simple statement, right? So this is not a combination of two or more simple statements. On the other hand, if I say that 2 is even and minus 3 is odd. Now basically this is a combination of two simple statements. 2 is even, minus 3 is odd. And therefore it is called as a compound statement. So how will you define compound statement? A combination of two or more simple statements will be called as compound statement. Okay? Yes. Now, the simple statements whose combination is a compound statement will be called as what? They will be called as constituents or components of the compound statements. I repeat, the simple statements whose combination is a compound statement will be called as what? They will be called as constituents or components of compound statement. Now we discuss logical connectives. The words or phrases which connect two or more simple statements to form a compound statement are called sentential connectives, or we can call them as logical connectives or simply connectives. So the words or phrases which connect two or more simple statements to form a compound statement will be called as sentential connectives or logical connectives or simply connectives. Now we are going to discuss 5 connectives with their truth tables. They are and, second one is or, third one is phrase, if, then. Fourth one, if and only if. IFF is the standard short form, if and only if. And fifth one is not. So we are going to discuss these 5 logical connectives. Now, the truth value of compound statement will depend on what? The truth value of a compound statement depends upon the truth values of its constituents. And of course, connective which is used to form that compound statement. Okay. Now we tabulate all these connectives and we discuss these connectives one by one. See, these are the logical connectives. The first connective is AND. Suppose P and Q are 2 simple statements. Then P and Q, this is the symbolic form of P and Q. Now the compound statement formed by using the connective word AND will be called as conjunction. Forget about this. We are not supposed to discuss this initially. Second one is OR. Now, if the connective word OR is used, we get a compound statement which will be called as disjunction. You must have heard about these words in English grammar. Now, this is the symbolic form. This is the symbol for OR. Then NOT, which is called as negation. This is the symbol which is called as TILDE. TILD, tilde. So while reading this, you have to read this as not P. If then, this phrase, it is called as conditional or implication. And this is the symbol. How to read this? P implies Q. And then if and only if. This is called as biconditional or double implication or equivalence. And this is the symbol for the 5th logical connectives, if and only if. Now we discuss these logical connectives one by one along with their truth table. So conjunction. Let me explain first. Now this is the symbol for conjunction. A compound statement formed by combining 2 given simple statements by the connective word and, and, is called the conjunction of the 2 given statements. Now this is the symbol used for the word and. If P and Q are 2 simple statements, their conjunction P and Q is written as what? Symbolically P. This is the symbol for and, P and Q. Okay. Now you have to use common sense. What can you say about truth value of the conjunction? Clearly, the truth value of the conjunction P and Q is T if both P and Q have the truth value T. In all other cases, P and Q is false. Now, how to make the table for this particular conjunction? The first column headed by P, second column headed by Q, and the third column will be headed by P and Q. Now, how many different combinations are possible? 4. Now, if you ask, but sir, order is immaterial, I agree with you. But in exam, you have to follow this order only. Especially in CET, they ask the entries in the last column are. Actually, this question is not correct because the order in which these 4 truth values are taken is immaterial. But still, they ask such type of question. So, you have to write truth values in this order only. So what will be the entries in the last column? True, false, false, false. See, this corresponds to intersection of 2 sets. In A intersection B, the elements which are present in both the sets will be included. So P is included, Q is included. That is why it is true. Now, element of P is there, but element of Q is not there, not allowed. Similarly, P is not there, but Q is there, not allowed. Both are not present. So this is again false. I hope this is clear to you. So how to remember the table for conjunction? Conjunction is true in only one case. Which case? When both are true. Now these two, P and Q in this case, are called as conjuncts. Conjuncts. Okay. So this is about conjunction. Then comes disjunction. This is not at all difficult. In fact, this is the simplest topic. Now, what is the symbol for disjunction? See, the symbol itself suggests inclusiveness. A compound statement formed by combining two given simple statements by the connective word or is called as disjunction. And as I said, this is the symbol for disjunction. If P and Q are two simple statements, their disjunction is P or Q, and this is the symbolic form of disjunction. Now these two are called as disjuncts, disjuncts. Now can you tell me about truth value of P or Q for different combinations of the truth values of individual statements? Yes. P or Q is false in only one case, when both are false. Otherwise, disjunction is true. So true, true, false, false. True, false, true, false. So this is true, 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 false. One student is asking, is it necessary that there should be only two statements? Not necessary. See, compound statement is combination of two or more simple statements. There can be three, there can be four. In fact, we are going to discuss a few compound statements which will be combination of three or in some cases four simple statements also. Okay, so this is about the second logical connective, that is disjunction. Now let us discuss the third one. It is actually not a word, it's a phrase. It is called as if then, and the compound statement form will be called as conditional or implication. This is very interesting, right? A compound statement formed by combining two given simple statements by the connective phrase if ... then is called the conditional or implication of the two given statements. Now, what is the symbol for connective phrase if then? See, this is the symbol. We have already used this. Implies, right? So if P and Q are two simple statements, then their implication is if P then Q. If P then Q. And symbolically, P, how to read this? P implies Q. Usually we go for this only, but this the second one is also correct, right? Now in this case, the first component, don't say P, because Q implies P is also an implication, and therefore I am saying that in implication the first component, in this case P, will be called as an antecedent. We have already used this word. I hope you remember that. In case of ratio A is to B, A is called as an antecedent and B consequent. Yes. So in case of implication, P implies Q, this first component will be called as an antecedent. There is one more name to it. It is hypothesis. and the second component will be called as consequent, and other logical name is conclusion. I repeat this. In implication, P implies Q. The first component P is called as an antecedent or hypothesis, and the second component Q will be called as consequent or the conclusion. Now the table is interesting. I mean truth table. P, Q, P implies Q. How to read this? P implies Q. Again, these four combinations, I repeat that ideally order is immaterial, but in exam you have to follow this order only, because they frame question like what are the entries in the last column of the truth table. So they expect you to consider the truth values of P and Q in this order only. Now many students, they find this difficult. See, the first two tables can be remembered easily. One for conjunction, other for disjunction. This is also not difficult. You have to remember that truth cannot imply false. Truth cannot imply false. Now, first combination, truth is implying truth, yes. In the second case, truth is implying false, not allowed, so false. Now, false can imply anything. That is why this is true. I hope this is clear to you. I'll give an example. If you join a coaching class, then you will get good marks. Student joins coaching class, he or she gets good marks, true. Student joins coaching class and he or she does not get good marks, no. Because if a student joins coaching class, then he gets good marks or she gets good marks, is the implication. So here, truth is implying false. Student has joined a coaching class and he or she is not getting good marks, not allowed. Now student hasn't joined coaching class, still he got good marks, possible, so true. A student hasn't joined coaching class, he's not getting good marks, true. I hope this is clear to you. If not, just remember that truth cannot imply false. So this is how you have to remember the table for implication. Okay? Yes. Now, the next one is called as biconditional. Actually, you can remember this table by saying that if there is a cause, CAUAC, if there is a cause, it must be accompanied by the effect. There is a cause, there is an effect, true. There is a cause, but it is not accompanied by effect. So how can we say that it implies? It is not implying, so false. If there is no cause, there may or may not be an effect. This means implication is false in only one case, when truth is implying false, when true rather is implying false. Okay. Now the next is biconditional or double implication. This is interesting. Biconditional, or I will not write that word, but double implication. Double implication. So this is the symbol for double implication. A compound statement formed by combining two given simple statements by the connective phrase if and only if. In short, we write it as IFF, standard short form for if and only. So it is called as biconditional or double implication of the two given statements. The connective phrase, as I said, that is written in short as IFF, and this is the symbol for this connective phrase. If P and Q are two simple statements, then their biconditional is P if and only if Q, that is P IFF Q. And we write this as P, how to read this? P biconditional Q. Or you can read this as P implies, this is interesting, P implies and is implied by whom? By Q. I repeat, P implies and is implied by Q. Now, when I say P implies Q, by that I mean P if and only if Q. P implies Q and Q implies P. P implies and is implied by Q, right? Or I can say that P is equivalent to Q. As the name suggests, can I say that P implies, rather P biconditional Q is nothing but P implies Q and Q implies P? Yes. And hence the name double implication. So what is double implication? It is P implies Q and Q implies P. Now, truth table for double implication. Now, this can be remembered easily by taking an interesting example. Let me tell you the statement first. The statement is equilateral triangles are equiangular triangles. I repeat the statement. P is the statement equilateral triangles. Q is the statement equiangular triangles. What do you mean by equiangular? Means each angle of a triangle is the same, means 60 degrees. Now, triangle is equilateral. All sides are equal. Triangle has all angles, rather triangle whose all angles are the same, equal. Is it possible? Yes, so true. Now, triangle is equilateral, means all sides are equal, but it is not equiangular. Means what? Triangle is equilateral, but each angle is not of measure 60 degrees. Is it possible? No, so false. Now, triangle is not equilateral, but each angle is of measure 60 degrees. Absurd. False. Triangle is not equilateral and triangle is not equiangular. All sides are not equal and all angles are not equal. True. So how to remember this table? Biconditional, that is double implication, is true when both truth values are the same. That is when both truth values are T, biconditional is true. When both are false, in that case also biconditional is true. I hope this is clear to you. Now, the last part, that is negation. Now, this is the symbol for negation. Now, many students use this symbol for negation. This is wrong. This is the symbol for negation. TILD. Okay. The connective word not, NOT not, operates on only one statement. When it is used at a proper place in a given statement, it forms a new statement which has a meaning opposite to that of the given statement. This new statement is called the negation of the given statement, right? So this is the symbol for the connective word not. Okay. Now the negation of a given statement can also be obtained. How? By using it is not true that, or we may say it is false that. For example, if I say P is statement, 2 is prime. 2 is prime. So its negation is denoted by not P. So what is not P? 2 is not prime, or it is not true that 2 is prime. It is false that 2 is prime. What will be the negation of negation? Obviously, negation of negation is nothing but original statement. Now, what is the truth table? It operates on single statement. So P, not P. When P is true, not P is false. And when P is false, not P is nothing but true. Is that clear? So that's it. This is about 5 logical connectives.
Exercise 1.1, question number 1. State which of the following are statements. Justify in case of statement. State its truth value. Five plus 4 is equal to 13.
Okay. First is 5 plus 4 equal to 13. Is it a statement? Write down. In exam, you have to say that it is a statement. Write down. It is a statement which is false. Because 5 plus 4 is not 13. So you have to say it is a statement which is false. Write down. Hence, its truth value is F, capital F. Hence, its truth value is F. Okay, which is the next one?
X minus 3 is equal to 14.
Now you tell me whether it is a statement or not. Yes, is x minus 3 equal to 14 a statement?
It is a statement.
It is a statement. No, it is not. Because a statement cannot be both true and false, or true in some cases, false in other. The same statement I'm saying. Because if x is 11, it is false. But if x is 17, it is true. So we are going to call this as an open sentence. Yes, it can be converted into a statement, but as it is not a statement. So write down. It is an open sentence. Write the solution. It is an open sentence. Hence, it is not a statement. Hence, it is not a statement. Yes, next one. Number 3.
Close the door.
Tell me the answer also. Is it difficult?
It is not a statement.
Right. So, what is the answer for the third one? It is an imperative sentence. See, don't write imperative statement. Write that it is an imperative sentence. Hence, it is not a statement. So, fourth one now. What is the fourth one? 0 is a complex number. Yes, what about whether it is a statement? Yes, it is a statement. Its truth value is T. Now, you will tell me about this later on. We'll discuss the statement later on that 0 is a complex number. What is the meaning of complex number? It is related to that only because 0 is 0 plus 0i, right? So every real number is a complex number. 0 is a real number, so it is a complex number. Now, fifth one. Please get me breakfast. Okay. So, fifth one, it is an imperative sentence. Hence, it is not a statement. Right now. See, this will be asked in exam. 3 marks, 3 sentences, 1 mark for each. So you have to write detailed answer, otherwise you won't get marks. Some rather sentence number 6. Congruent triangles are also similar. Okay. What can you say about this? Write down. It is a statement which is true. It is a statement which is true. Hence, its truth value is T. Seventh, x square equal to x. What can you say about this? Open sentence, because x square need not be x. If x is 3, is 3 square 9? No. So open sentence. So it is not a statement. But remember, we can convert it into a statement that we will discuss later on when we will discuss quantifiers. Now, rather question number 8 or sentence, 8th sentence. A quadratic equation cannot have more than 2 roots. Yes, it is a statement which is true. This is a statement which is true. Hence, its truth value is T, capital T. See, we are asked to find the truth value in each case. So we have to write that if it is a statement, of course. 9th, do you like mathematics? You will say that answer is yes or no. But when you say yes or no means 50-50. So this middle case is not considered in logic, right? So how will you express this? You can say that this is an interrogative sentence, right? Question mark. So it is an interrogative sentence, hence it is not a statement. In exam, you have to say for sum number 9, it is an interrogative sentence, hence it is not a statement. Tenth one, the sun sets in the west. Yes, it is a statement which is true. It is a statement which is true. Hence its truth value is T. Eleventh, all real numbers are whole numbers. It is a statement which is false. It is a statement which is false. Hence, the truth value is F. Next one. Can you speak in Marathi? It is an interrogative sentence, not a statement. Next. X square minus 6x minus 7 equal to 0 when x is 7, is it? Yes, it is. So it is a statement which is true. Hence, its truth value is T. For 13th,
The sum of cube roots of unity is 0. It is a statement which is true, hence its truth value is T.
very good. Sum of the cube roots of unity. I hope you remember this. 1 plus omega square. See, 1 omega omega square are the cube roots of unity. Their sum equal to 0. Very good. So this is a statement which is true. Hence its truth value is T. Now,
The 15th one, it rains heavily. It is an open statement, hence hence not a statement.
very good. It is not a statement. It is not a statement. Read the next question also.
Question 2, write the following compound statements symbolically. 1. Nagpur is in Maharashtra and Chennai is in Tamil Nadu.
Okay.
Let P be
No, no,
Nagpur is in
I'll
Maharashtra.
explain. I'll explain.
Okay.
So the first part, basically we are asked to write the compound statement symbolically. Now, compound statement is formed by joining, combining two or more simple statements. Okay. So the first statement given, compound statement given, is Nagpur is in Maharashtra and Chennai is in Tamil Nadu. So we have to say that let P stand for Nagpur. You have to write this. Nagpur is in Maharashtra. Right down. Q Chennai is in Tamil Nadu. Okay. After that, you have to say the symbolic form of the given statement is. Symbolic form of the given statement is. Now, which connective is used? And. P and Q. You have to use symbol only. Do not use the word A and D. Is that clear? Now, try to write solutions for remaining sums. Second, triangle is equilateral or isosceles. Let P be the statement that triangle is equilateral. Q be the statement that triangle is isosceles. So the symbolic form of the given statement is P or Q. Right? Third one. What is that statement? The angle is right angle if and only if it is of measure 90 degree. Okay, write down. Let P stand for the angle is right angle. Write down. Let P, the angle is right angle. Q, it is of measure 90 degree. It is of measure 90 degree. Then symbolic form is, see on the screen, P biconditional Q. P biconditional Q. This is for third one. Fourth, acute angle is neither, no, sorry, angle is neither acute nor obtuse. Okay. Write down. Let P stand for angle is acute. Let me explain this. If you have any difficulty, you can ask me. Angle is acute. Q, angle is obtuse. Let me explain first. Okay, then the symbolic form is not P and not Q. You may also say, let me complete. You may also say, we will say P angle is not acute. Angle is not obtuse, is Q. And then we will say P and Q. That is also correct. but generally we do not use negation in the original statement. So that is why I have written this as not P and not Q. Fifth one, if triangle ABC is right angled at B, then major angle A plus major angle C equal to 90 degrees. Right down. Let P denote, let P colon, let P triangle ABC is right angled at B. Triangle ABC is right angled at B. Q major angle A plus major angle C equal to 90 degrees. Symbolic form is P implies Q. This is conditional. Next, what is that? Hima Das wins gold medal if and only if she runs fast. Okay. Let P denote Hima Das wins gold medal. Q, she runs fast. Therefore, the symbolic form is P biconditional Q. Sum number 7. X is not irrational number, but it is a square of an integer. See, you can say that but means and. Okay. Now you may argue that we will define P as X is an irrational number. So it will be not P and Q. No problem. Or you may also say, write down, let P denote X is not irrational number. Let P denote X is not irrational number. Q, it is a square of an integer. It is a square of an integer. Symbolic form is P and Q. But if you say we will define P as what? X is irrational number, then your answer will be not P and Q. Question number 3. Write the truth values of the following. First one, 4 is odd or 1 is prime. So let P denote the statement 4 is odd, Q 1 is prime. So is the symbolic form P or Q. Actually, after this, we have to say that statement P is false because 4 is not an odd number. Statement Q is also false because 1 is not prime. Right? And then you have to say, therefore, truth value of compound statement is false or false is nothing but false. So what is the final answer? Truth value is F. Second, 64 is a perfect square and 46 is a prime number. Let P denote 64 is a perfect square. Yes, it is true. Q, 46 is a prime number. False. Now, given statement is P and Q, that is conjunction. Had it been disjunction, answer would have been true, but this is conjunction. So true and false, that is why it is false. In exam, after this, you have to say that truth value of, first should be P, who can both be Q. So here P is true, Q is false, and then you have to say So it is true and false, that is false. Third one, 5 is prime. Yes, it is. Second, 7 divides 94. No. So P is true, Q is false. And there, what is given? 5. Okay, and is used. So conjunction. Now true and false is false. So the truth value of the statement is F. Fourth one, it is not true that 5 minus 3i is a real number. Let P stand for 5 minus 3i is a real number. So the symbolic form of given statement is not P. Now P is false. So not P will be true. Fifth one, let P 3 into 5 equal to 8. Q 3 plus 5 equal to 15. Now what is the statement? If 3 into 5 is 8, then 3 plus 5 is 15. The symbolic form is P implies Q. Now P is false, Q is false. False can imply anything. So false implying false is nothing but true. Sum number 6, milk is white if and only if sky is blue. P, milk is white, Q, sky is blue. If and only if means biconditional. So both the statements are true. True, biconditional true is true. Then last one, 24 is a composite number or 17 is a prime number. Yes, 24 is composite. What do you mean by composite? In short, what is composite number? A positive integer that has at least one divisor other than 1 and itself. So composite. 17 is prime? Yes. So true or true is nothing but true. So that's it for today.